Okay. Good morning, students. So we have already started the waves chapter in the offline classes, and we have almost completed the 70%, 75-80% of the chapter in the classroom, and only we have not covered is principle of superposition. From the principle of superposition, this concept, the chapter of waves was not completed. So in these few videos, so today, tomorrow, day after tomorrow, in these few videos I will be continuing the remaining part of the waves, okay, from the principle of superposition of waves. So let us study the principle of superposition of waves. So far we have studied about the waves. When a wave propagates through a medium, the particles of the medium will vibrate. We have studied. When a wave propagates through a medium, the particles of the medium will vibrate or will oscillate, and the displacement of the particle of the medium is given by y is equal to a sin omega t minus kx. Like this you can, we have studied, and all these notations are known to you people. And then this is called as equation of a progressive wave. So now equation of a wave we have already studied. So now when a wave travels through a medium, the particles will vibrate. Okay. When there are a large number of waves traveling in a medium simultaneously, then what will be the resultant displacement of the particle? That is given by the principle of superposition of waves. So here once again I will tell, when there are large number of waves simultaneously traveling through a medium, then the displacement of a particle of a medium, the resultant displacement of the particle of the medium is given by the principle of superposition of the wave. So what is this principle of superposition of wave? So according to principle of superposition of wave, the resultant displacement of the particle of a medium, the resultant displacement of particle of medium at any instant of time is given at any place or at any instant of time is given by the sum of displacement caused to the particle by the individual waves. That is, the resultant displacement of a particle of a medium at any instant of time is equal to the sum of displacement caused to the particle by the individual waves. Let us say there are two waves traveling in the medium. Let us say the displacement in the particle due to the first wave is y1, and displacement of the particle due to the second wave is y2. When these two waves travel simultaneously, then the resultant displacement, that is resultant displacement of the particle of the medium, is equal to the sum of displacement caused to the particle by the individual waves. That is y is equal to y1 plus y2. This is called principle of superposition of wave. Or you can write, if there are three waves, then y3 plus, if there are n number of waves, so you can keep on writing. Understood? This is called principle of superposition of waves. Here once again I will repeat, when two or more waves superimpose or overlap on each other at a point or in a medium, the resultant displacement of the particle of the medium is equal to the sum of displacement caused to the particle by the individual waves. That is, y is equal to y1 plus y2. Y is called resultant displacement, y1 is called displacement of the particle due to the first wave, y2 is the displacement of the particle due to the second wave, and y is the displacement of the particle due to the both the waves, both the waves. Understood? Okay. So this is called principle of superposition, and by using this principle of superposition we can understand or we can study about the interference of light, interference of waves, interference of light, that will comes in the second year, interference of waves. Also by using the principle of superposition we can study about the stationary waves, and also we can study about the beats, These three concepts, that is interference of waves, stationary waves and beats are studied by using the principle of superposition of waves. So first let us understand interference of waves. Let us understand interference of waves. Let us understand interference of waves. Interference of waves. The superposition of two or more waves. The superposition of two or more waves having the same wavelength, same amplitude and frequency. The superposition of two or more waves having the same wavelength, same amplitude and same frequency, traveling in the same direction with the same speed. The superposition or overlapping of two or more waves having the same wavelength, same amplitude and same frequency, traveling in the same direction with the same velocity will give rise to a resultant third wave. Will give rise to a third wave whose amplitude is different. Will give rise to a third wave whose amplitude is different from these waves. This phenomenon is called as interference of waves. Here, interference of waves. The phenomenon in which two or more waves having the same wavelength, same amplitude and same frequency, traveling in the same direction with the same velocity superimpose. After superimposition, a third resultant wave is produced. A third resultant wave is produced whose amplitude is different from the waves, superimposing waves. And this phenomenon is called as interference of waves. Understood? So this principle, actually this interference of waves exclusively, completely you will study in the second year. Just introduction is here in the first year. So interference of waves. And there are two types of interference. One is called constructive interference. One is called constructive interference and another is called destructive interference. Okay. One is called constructive interference and another is called destructive interference. Okay. First let us understand constructive interference. Constructive interference of light. Interference. Interference. Okay. So now constructive interference. Here through the diagram I will explain. So constructive interference takes place when two waves of same amplitude, same wavelength, having same frequency, traveling in the same direction with the same velocity superimpose on each other such that the third wave produced, such that the resultant wave produced will have maximum amplitude. Two waves or two or more waves having the same amplitude, same wavelength, same frequency, traveling in the same direction with the same velocity superimpose on each other such that the resultant wave produced will have maximum amplitude. Then the interference is called constructive interference, and this maximum amplitude is possible. This maximum amplitude is possible here when a crest of one wave falls on the crest of another wave. Let us say interference of transverse waves. Let us say interference of, just for our understanding, we will say a transverse wave. So now this is one wave. Let us say this is first wave, transverse wave, and displacement of this wave is y1. And this is called crest and this is called trough. We have already studied all these things. And along y-axis it is displacement, along x-axis it is time. Time is taken along x-axis, or phase phi is taken along x-axis. Okay. So this is first wave, and the first wave is the displacement of the first wave is y1. And now second wave, there is another wave such that both the waves are superimposing on each other or overlapping on each other, and the resultant displacement will be maximum. This is second wave. Let us say this, the displacement of this second wave as y2. The displacement of the second wave as y2. See here, the amplitude of the resultant wave will be maximum when a crest of one wave falls on the crest of another wave. This is crest of the first wave. This is crest of the first wave and this is crest of the second wave, and crest of the first wave falls on the crest of the second wave and trough of the first wave falls on the trough of the second wave. Then the third wave generated, the resultant wave produced will have maximum amplitude. So this is the resultant wave produced. This is the resultant wave produced. Diagram completed. This is the resultant wave produced. This is the third wave produced. So the resultant wave produced will have maximum amplitude. Then it is called constructive interference. Understood? So got the idea? So it is, and the phenomenon of this interference can be studied by using the formula y is equal to y1 plus y2. Y is equal to y1 plus y2, and the resultant amplitude of the resultant wave is given by r is equal to, there is a formula called a square plus b square plus 2ab cos phi. This is the formula for the r is called as the amplitude of the resultant wave, a is called as the amplitude of the first wave, b is called as the amplitude of the second wave, and phi is called as the phase difference between the two waves. And now crest falls on the crest and trough falls on the trough, but that means both the waves are in phase. Both the waves are in phase. Then the amplitude of the resultant wave becomes maximum. Understood? Okay. So this is constructive interference. Similarly, you can also understand about the destructive interference. This much is enough for the first year. This much is enough. Just introduction. Okay. So now destructive interference. Destructive interference. Here, in the destructive interference, same. The superposition of two or more waves. The superposition of two or more waves having the same wavelength, same amplitude and same frequency, traveling in the same direction with the same velocity, superimpose on each other and gives rise to a third wave. Gives rise to a third wave whose amplitude is minimum. Whose amplitude is minimum. Then this is called destructive interference. So if the amplitude of the resultant wave is minimum, then it is called destructive interference. So now by the diagram I will explain how this destructive interference takes place. So this is graph. There is displacement is taken along a y-axis and the time or phase is taken along a x-axis. Okay. So now this is first wave. It is first wave y1. So this is first wave y1. Y1 is the displacement of the medium due to the first wave y1. Okay. Now second wave. See here, second wave and first wave has to overlap on each other such that the displacement, the resultant displacement must be minimum. Then the crest of one wave falls on the trough of another wave. This is second wave. See here, this is second wave. This is trough of the second wave and this is crest of the first wave. The crest of one wave falls on the trough of another wave and the trough of one wave or crest of one wave falls on the trough of other wave. Then the amplitude of the resultant wave becomes minimum. The amplitude of the resultant wave becomes minimum and it is called destructive interference. So then the resultant wave is given by, this is two individual waves. This is first wave and this is second wave y2. And now after overlapping of these two waves, the resultant wave is given by this one. This is called a resultant wave. The resultant wave will not have larger amplitude. It will have smaller amplitude. The amplitude of the resultant wave will be smaller. And this theory can also be studied by using the formula y is equal to y1 plus y2. And the amplitude of the resultant wave is given by the formula r square is equal to a square plus b square plus 2ab cos phi. So this is gives the amplitude of the resultant wave. This r square, this r is called as the amplitude of the resultant wave. And now the amplitude of the resultant wave will be minimum when cos phi is minimum, or when the two waves superimpose out of phase. Two waves superimpose out of phase, that is these two waves y1 and y2 are not in phase, they are out of phase, and out of phase they are overlapping on each other. Then the resultant wave will have minimum displacement. Resultant displacement will be minimum. So then this is called destructive interference. Understood? So this is about destructive interference. This much is enough. So just same formula we will use. So some of the books may write like this also. It is y is equal to y1 minus y2 also they will write. That is when out of phase, then y is equal to y1 plus y2. So this is out of phase. So this is starting from the down. So we have to write it as minus. So y is equal to y1 plus minus of y2. So then you will get y is equal to y1 minus y2. So that is also, and final answer, the amplitude of the resultant wave comes out to be same. But here cos phi, that is the value of cos phi will be minimum, or phi will be, that is out of phase. That phase difference is not constant. Phase difference is not constant. Understood? So this is about destructive interference, and exclusively we will study about this constructive interference and destructive interference in the second year. Just introduction is there in the first year. Okay. So now the next concept. So next concept is stationary waves. That is very, very important. Stationary waves, and that is also studied by using the principle of superposition. By using the principle of superposition, we can study about the interference of waves, we can study about the stationary waves, and we can also study about the beats. Just now I explained about the interference of waves. Now I will explain about the stationary waves. Understood? Stationary waves. Stationary waves. The concept of stationary waves. Okay. This is also from the principle of superposition of waves. From the concept of principle of superposition of waves, we can understand the stationary waves. Okay. When two identical waves of same amplitude and frequency, when two identical waves of same amplitude and frequency traveling with the same speed in the opposite direction. Listen to carefully. When two identical waves of same amplitude and frequency traveling with the same speed in opposite direction, superimpose on each other, then a wave is produced which does not appear to be traveling on either side, and it is called a stationary wave. That is, when two identical waves of same amplitude and frequency traveling with the same speed in the opposite direction overlap on each other, then a wave disturbance is produced which does not travel either direction, does not travel in this direction or does not travel in this direction, then that wave is called stationary waves, or it is also called as a standing wave. Listen to carefully. Two waves of same amplitude and same frequency. So let us say this is one wave, Sumka, just for your understanding, this is one wave having the same amplitude, same frequency, and then another wave which is traveling in the opposite direction having the same amplitude and same frequency. But this wave is traveling in the opposite direction, this wave is traveling in the, both the waves are traveling in the opposite direction and they will overlap on each other. Then a resultant wave disturbance is created which does not appear to be traveling. That wave disturbance or that disturbance is called as stationary waves. That is, or it is also called as standing waves, or it is also called as stationary waves. Okay. So now a stationary wave is produced. A stationary condition. What is the condition for the production of stationary wave? A stationary waves cannot be produced by two individual waves. Remember that two individual waves traveling with the same speed and having the same amplitude and same frequency in opposite direction cannot produce the stationary waves. Two individual waves cannot produce the stationary wave. A stationary wave can be produced by one wave and the superposition of one wave and the other wave, which is the reflection of the first wave. The superposition of a wave and its reflection will give the stationary wave. A stationary wave can be produced by a wave and its reflection part. That is, one wave is traveling and whose reflection, we have studied about the reflection of waves. So reflection of that wave, so both reflection wave and incident wave, both when both are identical nature wave, superimpose on each other, then a stationary wave can be produced. But two individual waves cannot produce the stationary waves. Remember that? So therefore, a stationary wave can be produced in a bounded medium. A stationary wave can be produced in a bounded medium, that is in a fixed medium or fixed medium. That is, for example, a string fixed at both the ends. A string fixed at both the ends will have stationary waves. That is, a wave is created, a wave disturbance is created which is traveling in this direction from left to right. Then it will get reflected at this boundary, and the reflected wave and the incident wave both overlap on each other and gives rise to the stationary wave. And also, a stationary wave can be produced in a gaseous medium or liquid medium in a column of pipe. Let us say this is a pipe, and this pipe has a medium, gaseous medium, and in this gaseous medium is also a wave is incident, and this wave undergoes reflection at this point, and after reflection the reflected wave and incident wave both overlap on each other, gives rise to the stationary waves here. So this is called a bounded medium or medium whose boundaries are separate from outside. A medium whose boundaries are separate from the outside, in such a medium these stationary waves are produced. Remember that stationary waves cannot be produced by two individual waves, so independent waves. The stationary waves can be produced by one wave and the reflection of that wave. Understood? So therefore, stationary wave can be produced on a string, or stationary waves can be produced on a air medium in a pipe or air column in a pipe. Okay. So there are two types of stationary waves. One is called transverse stationary waves, another one is called longitudinal stationary wave. Transverse stationary waves. Transverse stationary waves. That is stationary waves produced by transverse waves. That is stationary waves produced by overlapping of transverse waves is called transverse stationary waves. And the example for this transverse stationary waves, that is the waves produced on a vibrating string of a sonometer. So there is an experiment called sonometer. In that sonometer there is a vibrating string. So that vibrating string will produce us a waves. This waves can be, this is a string. On this string one wave is incident and the reflected wave will come, and then a reflected wave and incident wave both will overlap and they will produce the stationary wave. Or on the wires of the instrument, like some sitar, guitar, there will be a musical instrument, that musical instrument wires are fixed between the two fixed boundaries, and then when disturbance is produced in one wire, so then that disturbance is reflected back, and then a reflected wave and the incident wave both together will produce the stationary wave. So it is called transverse stationary wave. A stationary wave is produced in a vibrating wire or vibrating string of a between two fixed supports is called transverse stationary waves. And the longitudinal stationary waves, that is longitudinal stationary waves, that is the stationary waves produced due to the overlapping of longitudinal waves. Simple. The stationary waves produced due to the overlapping of longitudinal waves, we can call it as longitudinal stationary waves, and longitudinal stationary waves can be observed. An example for that longitudinal stationary waves is in a air medium inside a pipe. A pipe is there. This is a pipe. So a pipe, and in this pipe there is a air medium. In this air medium, so when there are two waves, that is one is incident wave, another one is reflected wave, and both the waves overlap on each other, then a stationary wave is produced, and it is called as a longitudinal stationary wave. Longitudinal stationary waves is produced in a this is called as resonance apparatus. It is also called as a resonance apparatus. Resonance apparatus or Court's apparatus anta karitare. So in that, so this longitudinal stationary waves can be observed. Understood? Okay. So now, so let us understand the characteristics of stationary waves. This is important. Characteristics of stationary waves. Characteristics of stationary waves. Okay, some more thing I will explain. characteristics of stationary waves later. So during the formation of stationary waves, let us say, just for your understanding, this is one wave, this is the incident wave, and it gets reflected here, it gets reflected here, and the reflected wave, and this is reflected wave, this is reflected wave, and the incident wave and reflected wave both overlap on each other and both are traveling in the opposite direction, and they will form a stationary wave. They will form a stationary wave. So when a stationary wave is formed in a medium, so when a stationary wave is formed in a medium, so there is the disturbance, that is the disturbance does not travel from one place to another place, that is the disturbance is there only, that is the wave either does not travel in this direction and that direction. So but the particles of the medium will have vibration, but some of the particles of the medium are permanently at rest. Some of the particles of the medium are permanently at rest, and that points, the points where the particles of the medium are permanently at rest, that points are called as nodes. The nodes are the points where the particles of the medium are permanently at rest. Nodes are the points where the particles of the medium are permanently at rest, and there are some other positions in the medium where the particles of the medium will have maximum displacement. The particles of the medium will have maximum displacement. Displacement is maximum, and that points are called as antinodes. That points are called as antinodes. So these all are called antinodes. This point is called antinode. This point is called node. This is called node. This is called antinode. This is called node. So like this, so a stationary wave is formed. So now the characteristics of a stationary wave, just for your understanding, I told about this. Okay. So now first point, a stationary wave is formed in a bounded medium. A stationary wave is formed in a bounded medium, that is a medium whose boundaries are separate from the outside. That kind of medium, in that kind of medium a stationary wave is formed. And next, in this bounded medium there will be some points which are permanently at rest. In this bounded medium, when the stationary wave is formed, there are some points which are permanently at rest, and these points are called as nodes. These points are called as nodes, and they are denoted by n. In this bounded medium, a stationary waves are produced in a bounded medium, it is the medium whose boundaries are separate from the outside. So in such a medium, these stationary waves are produced. Second point, in that bounded medium there will be some points, there will be some positions where the particles of the medium are at rest. That positions or that points are called as nodes. They are called as nodes. And third point, in that bounded medium there will be some positions or there will be some points where the particles of the medium will have maximum amplitude or maximum displacement. There is maximum displacement. The particles of the medium will have maximum displacement at certain other positions, and these positions are called as antinodes. These positions are called as antinodes. Understand the characteristics properly. First point, stationary waves are produced in a bounded medium. Second point, in that bounded medium there will be some points or some positions of the medium where the particles of the medium are permanently at rest, and that points are called as nodes. And in that medium, in that bounded medium, there will be some positions or some particles of the medium which are having a maximum displacement, and that positions are called as antinodes. And the fourth point, the distance between the nodes, the two successive nodes, the distance between the two successive nodes is lambda by 2. The distance between the two successive nodes is lambda by 2. The distance between the two successive nodes is lambda by 2, and the distance between the node and a antinode, and the distance between the node and a antinode is lambda by 4. The distance between the node and antinode is lambda by 4. This is lambda by 4. The distance between node and antinode is lambda by 4, and the distance between the node is lambda by 2. Or the distance between the two antinodes, the distance between the two antinodes is also lambda by 2. Or you can say distance between two antinodes is also lambda by 2, or the distance between the two nodes is also lambda by 2. and the distance between the node and antinode is lambda by 4. The distance between node and antinode or antinode and node will be lambda by 4. Understood? And next, fifth point, when a stationary wave is formed, the medium is divided into segments. The medium is divided into in large number of segments between two equally spaced points. Between two equally spaced points, that is called nodes. These nodes are equally spaced. The nodes are equally spaced point, and between the equally spaced points, the medium is divided into segments or portion. This is called one portion, this is called another portion. Between the two nodes, this is one segment, this is called another segment, like that. Okay. And all the particles of the medium lying between the node will vibrate with the same phase. All the particles of the medium, the lying between two nodes will vibrate with the same phase. The particles of the medium lying between the two successive nodes vibrate with the same phase, and they pass through the mean position simultaneously. All the particles pass through the mean position simultaneously, and all the particle attains the maximum displacement simultaneously. So like that. And here also, between the two nodes, all the particles will have the same phase. Next, fifth point, that is seventh point. But the particles between the two segments, the particles of the two segments will not have the same phase. That is, the state of vibration of the particle of this segment will be different, and the state of vibration of the particle of this segment will be different. So let us say, if these particles are moving upward, then these particles lying between these two nodes will be moving downward. That is, there will be a phase opposite. The phase of these particles will be different. The phase of all these particles will be same. And the phase of all these particles between these two nodes, all the particles will have the same phase, and between these two nodes all the particles will have the same phase. But the phase of particles between this segment and the phase of particle between this segment will be opposite. Understood? The particles between the two segments will have opposite phase. That is, if these particles are moving upward and these particles will be moving downward. Understood? Like that we have to understand. And next, seventh point and eighth point, there is no transfer of energy from one particle to another particle. In a stationary wave, there is no transfer of energy, or there is no transfer of disturbance from one particle to another particle. So transfer of energy does not takes place. So these are some characteristics. So there are large number of characteristics still you can study. So these are some important characteristics that you must know about the stationary waves. So here once again I will repeat. Stationary waves are produced in a bounded medium. And second point, in that bounded medium there will be certain points where the particles of the medium are permanently at rest, and that positions is called nodes. And in that medium there will be certain other points or certain other positions where the particles of the medium will have maximum displacement, and that points are called as antinodes. And the distance between the node and node, or distance between antinode and antinode will be lambda by 2, and the distance between the node and antinode, or antinode and node will be lambda by 4. And the particles, when a stationary wave is formed, the medium is divided into segments, between two equally spaced points. These equally spaced points are nodes. That nodes and antinodes are equally spaced points, and between the two equally spaced points called nodes, the medium is divided into two segments. So next is 6th point, all the particles of the medium which are lying in the between two nodes will have the same phase. That is, between these two nodes all the particles will have same phase, and between these two nodes all the particles will vibrate with the same phase, and they cross the mean position simultaneously. They attain the maximum displacement simultaneously. And 7th point, there is a phase difference. The phase between one segment and another segment will be opposite. That is, there will not be same phase. That is, the particles in one segment will be in one phase and the particles in another segment will be in another phase. The phase will not be same. The segment wise the phase will be different, but in this fixed segment the phase of all the particles will be same. And 8th point, there is no transfer of energy. There is no transfer of energy from one particle to another particle when a stationary wave is formed. And further some more points also you can write. It is all the particles will have different amplitude. The particles will have different amplitude. The amplitude is 0 at the nodes and amplitude is maximum at the antinode. So amplitude increases from node to antinode. The amplitude, the particles of the medium will vibrate with different amplitude. The amplitude is 0 at the nodes and amplitude is maximum at the antinode. So like that. And the particles of the medium will also vibrate with particle velocity will be different. The particle velocity will be different. The particle velocity is 0 for the particle which are at the nodes and the particle velocity is maximum for the particle which are at the antinodes. So these all are some more points which you can study under the characteristics of a stationary wave. So these all are the some characteristics of a stationary waves. Study these characteristics properly. Okay. So for this class this much is enough. In the next class we will study some more concept about the stationary waves. Okay.